This question involves a redox reaction, more than one redox reaction actually. First, we have a student adding 3 moles of acidified potassium dichromate 6 to an excess of iodide ions. Okay, and the chromium in this dichromate 6 ion are all reduced to chromium 3. So Cr2O7 2 minus all the Cr in here, they are all reduced to chromium 3. And the iodide ions are all oxidized to iodine. So I'm going to write an equation to find the stoichiometry of this redox first. So I have chromium, okay, Cr2O7 2 minus chromium in dichromate ions reacting with iodide ions. Okay. All of this, okay, will eventually form chromium 3, all the chromium in the dichromate 6, okay, will turn into chromium 3 ions, and iodide will become iodine. Okay, that is oxidation. In this Cr2O72 minus ion, I have 2 Cr. So let me balance the number of Cr atoms first. So 2 Cr here, then I have 2 Cr that are formed from the dichromate, right? And iodine, also the same thing. I have 1 iodide here, but here in iodine I have 2 I. So let me balance the number of I on both sides. Now I want to find the oxidation number of chromium in dichromate ions. Okay, that would be plus 6. Oxidation number of chromium in the chromium 3 ion will be plus 3. Okay. So what is the change in oxidation number of chromium from dichromate ions to chromium 3 ions? Now we have to multiply by 2 because the change comes in the package, right? 2 Cr here to 2 Cr here. So the change will be from plus 6 multiplied by 2 to plus 3 multiplied by 2. So that means, okay, from plus 12 to plus 6, the change, okay, is reduced by 6. Okay, because plus 12 minus 6, we will get plus 6. So in this reduction, oxidation number changed from plus 12 to plus 6, that is reduced by 6. Now let's look at oxidation from iodide to iodine. Okay, in iodide, oxidation number of iodine is minus 1. In iodine, oxidation number of iodine is 0. So again, the change will be from minus 1 multiplied by 2 because we have 2 iodide forming 2 iodine, okay, becomes 0. So the change here will be from minus 2 becomes 0. So the change is increased by 2. That's why I put a plus 2. Now we need to balance these two numbers. Okay, here I have changed one drop by 6, the other one increased by 2. It's not balanced. I need here to drop by 6, here increase by 6 also. So that means here, okay, what happened is the chromium will donate 6 electrons. So I need enough iodine to accept the 6 electrons, then only, the equation is balanced. So I multiply this by 3 so that I can get plus 6. Now you see the magnitude is the same. Okay, so now transfer electrons are balanced. I need to make the equation balanced also. I multiply iodine by 3. So 2 multiplied by 3. Okay, I should get 6 here. There's a 1 in front of this iodine, multiplied by 3. So there's a 3 in front of iodine. Now I can rewrite this whole equation. Okay, I'll probably use a different color. Okay, to rewrite the whole equation, it will be Cr2O72 negative plus 6 iodide. Okay, I get 2 chromium 3 and 3 iodine. So that's from this balancing of electron transfer, we get the stoichiometry correct. Now from this equation, I can see that the number of mole of Cr2072 negative, the dichromic ions, to the number of mole of I minus iodide, okay, to the number of moles of iodine. Okay, the ratio will be 1 to 6, okay, to 3. Okay, then now let's look at the question again. Okay, it says that the students add 3 moles. I have 1 to 6 to 3. So I use 3 moles, the student uses 3 moles of potassium dichromate ions. So I have to change this to 3. Okay, let's continue here. Okay, and Cr2O7. Should have written here, but it's okay. Let's rewrite. Okay, so from here 1 to 6 to 3. Now I'll have to start with 3 because student uses 3. Right, so if this is 3, I multiply this by 3. I have to multiply the rest by 3 also. So the number of moles of iodide will be 80. Number of moles of iodine, oops, sorry about that one. I shouldn't have written it as a subscript. It should be, oh sorry, superscript. It should be a subscript. Okay. So number of mole of iodine will be 9. Now, we have not done with the question because here we have the further part. It says that, oh, now iodine, okay, is reduced back to iodide by X mole of thiosulfate ions, right? And they give us, oh, if we have 1 mole of iodine, okay, we will need 2 moles of thiosulfate ions to reduce it back to iodide. So the ratio of iodine to thiosulfate ions will be 1 to 2. Okay, again, because they say 1 mole of iodine is reduced by 2 moles of sulfate. Okay, so this is the ratio. But in this case, in this experiment, what happened is, okay, we are using 3 moles of dichromate ions. So that means the amount of iodide being reduced by 3 moles of dichromate ions will be 18 moles, and 18 moles of iodide will form 9 moles of iodine. If we have 9 moles of iodine, that means I have to multiply this by 9, I have to multiply this by 9, so the number of moles of thiosulfate needed in this case will be 18. Okay, so what's the value of X? What's the amount? Okay, the number of moles of thiosulfate needed to reduce all the iodine here back to iodide, okay, will be 18. So the answer is